Congratulations for all participants of conference. I'm Taras Dalyak, researcher at Research Institute for Applied Problems in Mechanics and Mathematics, National Academy of Science of Ukraine. Let me introduce you an investigation about equilibrium of an elastic plate with parallel contact cracks under asymmetric bending. The symboled elements in structures are widely used in mechanical engineering and machine building. The crack line defects in plate or shells may significantly reduce the operating time of both separate elements and whole mechanism. Under the action of the bending components of the load, the crack edges can interact due to the closing effect. In this case, the stress-strain state is distributed as the defects tip, and as a result, the calculated parameters of the limited equilibrium.
Sorry, I need to interrupt you for a second. Can you show us slides if not problem? There's still the beginning one.
Yes, yeah.
Thank you.
Okay, sorry. Hence, the investigation of the stress state in thin bullet elements, taking into account defects closure, is currently a relevant problem of fracture mechanics. The interaction of through thickness defects in bending plate without taking into account the defect edges interaction was studied using by classical theory and Treisner's theory. The main approach to the modeling of the cracks closure in bending plate is a model of smooth contact along the line using the classical bending and plate stress strain theories. The main of this investigation is to study the influence of crack closure on the stress strain state of the infinite plate under asymmetric bending. Let's consider the infinite isotropy plate in thickness 2 times h, which is when a straight line cross-cutting parallel cracks in length 2L, figure 1, located at the distance d. The crack edges are loaded by uniformly distributed moment of different sign, the arrows. The plane is free from stress at infinity. The influence of the contact interaction of the crack edges on the stress strain state of the plate is investigated. Since the crack edges contact under bending leads to the antisymmetric breaking of the stress field and displacement along the thickness of the plate, the stress state of the plate outside the crack is described by a pair of biharmonic equations of plane stress state and the classical theory of plate bending, the formula 1. Phi is an area stress function and W is a plate deflection. Membrane forces and bending moment at infinity are equal to 0, and the contact of edges of the cuts is interpreted as a closure of their sharp edges in one of the front surface in the plate according to the Kirchhoff's assumption about the rigid normal. With the approach, the real two-dimensional contact region transfers into a line. In addition to the jumps of normal reaction angles, displacement discontinuities occur in the middle surface of the plate. This boundary condition is described with formula 3. The first equation describes the non-penetration kinematic the condition, and the second one is static condition. And here we can see the non-equal to 0 the stress along the stress force membrane forces is not equal to 0. Also, we have an taking into account the symmetry and antisymmetry of the displacement fields relative to the abscissa axis, it's possible to consider the boundary condition only the one cut. Here we see the symmetric and asymmetric properties. Then we have some integral expression to with of force and moments on the crack in terms of the derivatives of the unknown function of jumps and of displacement and rotation angles. Where here there are some kernel expression that contains singularity parts and regular parts. Also non-dimensional variables and the constant. If to substitute the equation 4 to the boundary 3, we and assuming that the closure of the section occurs through the entire length, we obtain a system of integral equation of the problem. Formulas 5 and additional to this system, we should be solved under additional condition of displacement and rotation angles and ambiguousness. A asymptotic solution of problem 5 and 6 at large distance between defects was constructed using the small parameter method. Here we can see the formula 7. It's worth noting that by formal substitution kappa is equal to 0 in formula 7, we obtain a solution to a similar problem without taking into account the contact of the crack edges. And the last one expression is the expression for the contact direction of closed cracks edges. The numerical solution of the problem 5 and 6 is constructed by the mechanical quadrature method, figure 2. It shows the graphical dependencies of the intensity factors of forces and moments on the parameters lambda, obtained at nu is equal 0.3. The solid curves indicated the numerical results, and dashed curves correspond to the asymptotic dependencies. As can be seen from the figures below, the contact interaction of the cracks edges leads to a significant decrease in the moment intensity factor, K3, and to the appearing of the non-membrane forces intensity factor, K1. When the cracks approaches with increasing lambda, the stress concentration near the tips increasing in the lack of the defects edges contact, green lines, and decreasing for the contact cracks, the red lines. This effect differs from the cases of crack interaction under condition of symmetric bending. The appearance of the screening effects for bending of a plate with parallel possible cracks can be explained by the significant influence of the contact inducted plane stress state. The next slide shows the distribution of the contact reaction on the closed edges of the cuts at different values of the parameter lambda. When the cracks approaches each other, the contact interaction increases, especially in the middle of the crack. It should be noted that the contact inequality 3 along the entire cut line is ensured in the studied range of changes of the parameter lambda. Let me show you the conclusion. Using the contact model along the line, the problem of closure of two parallel cracks under antisymmetric bending of plate was investigated. The membrane components of the stress field generated by the contact of the edges prevails for the corresponding moment of the bending moment. Taking into account the interaction of the edges of the cracks changes not only the quantitative picture, but also the quality one, namely the stress concentration near the tips increases in the lack of defect edge contact and decreases for contact cracks. Thank you for attention.